Medical mycology. So introduction to the basics. Myx, Greek word. It's a Greek word. It's term mushrooms. I think we have seen mushrooms, eaten mushrooms. So mushrooms are fungus. They are eukaryotes. So they are differ from bacteria and other prokaryotes. What are the peculiar features? So specifically, cell wall contain chitin. It support and also provide a rigidity. Also contain mannane and other polysaccharides. About cytoplasmic membrane, it contains ergosteroids. Ergosteroid. Also, it contains true nuclear with the nuclear membrane and also paired chromosomes. They divide sexually or by both. Also, they are unicellular or multicellular. Their diverse group contain more than 90,000 known species. They are chemoheterotrophs. Also, they are saprophytes. They digest dead and dying organic matter. They are parasites, one way, obtain nutrients from tissues of organisms. There are terminology moles and mushrooms are multicellular. Yeast are unicellular. You can see multiple types of different types of fungus or mushrooms. Larger one, smaller one, different colored one, likewise. How fungus are nourished, how they take their nutrients. As I said earlier, they are chemoheterotrophs. Absorption of nutrients by the secrete exoenzymes. So by use of exoenzymes, they digest these macromolecules and absorb their cellular membrane. Compared to bacteria, they grow at lower pH, around 5 like pH. Also in high salt and sugar concentrations, they are able to grow. But bacteria often they tend to osmolize. Here, because they contain chitin, they say provide rigidity to cell wall. Metabolize complex carbohydrates like lignin in wood roots. So another mode of nutrient. Structurally, the two differ used by means of yeast. I said earlier they are unicellular, nucleated around fungi, while moles are multicellular filamentous fungi. You know filamentous bacteria now, actinomycetes. Here they are more or less similar, but bacteria here it is a fungus. Is produced by process called budding, while moles produce spores to reproduce. Some is the opportunistic pathogens. In that sense, they cause disease in immunocompromised individuals. There are other use benefits. Yeast are used in preparation in variety of foods. About the diseases called fungal disease or mycosis. There are less than around 100 in human infection. They are not highly contagious. Human acquired by nature. Groups or disease groups we can classify based on degree on tissue involvement and mode of entry. Cutaneous mycosis, one example, you have seen almost dermatophils. It involved in epidermis, hair and nails. Contagious, it's rather contagious. Direct or indirect contact, it's spread. Secrete keratinase that is capable to degrade keratin in skin. That's how they survive. Predisposing factors. Use of antibiotic, irrational use, broad spectrum use, prolonged use of steroids, immunosuppressive conditions like infections, HIV/AIDS, chemotherapy, malignancies, they are more prone to develop this kind of fungal infection. Bit of morphology, specifically, you can see hyphae traits making up the mycelium. This is the hyphae. When hyphae are mixed, it's termed mycelium. You can see a mycelium. Here it is yeast or unicellular structure. It's a capsulated one here. See, not all are capsulated. This is the Indian Cryptococcus species. You can see nice capsule wide. So they divide by body, making another progeny. Here in about the moles, they produce spores. Spores do spread on air, then they develop their progeny. That's you can see yeast. Very likewise, different species having different character, different form of different morphologically differ yeast as well as fungal moles. Here some are dimorphic, so that means they possess in both shapes. Yeast other way hyphae, forming hyphae at ambient temperature, but yeast at body temperature. Yeast is capable in extracting nutrients from tissues. So this is less adaptive form, but in ambient temperature, it's less nutrient compared to human or animal body. So they produce larger, they increase their surface area you forming this mycelium. By the end of this large surface area, they tend to absorb nutrient from the environment where they live. So it's a one-way biological adaptation. But some fungus, they are dimorphic, not all. Some only yeast. They are in unicellular species like Cryptococcus. Some may have a hyphae only, that is aspergillus. But blastomycosis, coccidioides, histoplasma like they are dimorphic. So now I think you are familiar with this simplest unicellular budding yeast, tibular elongation. That's how it on hyphae. Mycelium, what I said. Then filamentous. Also, there are a few about here it's filamentous fungi. Here it is, there is a demarcation. So term septate is a proper septate, true septate. So some are aseptate. Here all are, you can see no septate. Here you can see a septate. Aerial mycelium, vegetative mycelium. If they in a growth in the media, culture media, it's termed vegetative mycelium. It's in aerial ambient temperature, that's a mycelium. It's rarely seen in clinical. You can further about the elongation. Go in the tip elongation. You can see the nucleus, mitochondria, prophytoplasmic reticulum, Golgi apparatus because they are eukaryotes. Cell morphology now we are familiar. Yeast is like fungi, moles, dimorphic fungi. So yeast, unicellular. Cryptococcus neoformans is a good example. Here it is yeast like fungi, not really yeast. It's form pseudo. Candida albicans is one. You can see it's unicellular or cellular component is there, but they arrange like hype. But it's not a true hype, it's pseudo hype. Moss filamentous fungi, you can see nicely septate there, elongated filamentous fungi. Here rhizopus smooth bit of evolution in the lower terms compared to aspergillus. But they possess disease in immunocompromised individuals. Dimorphic, I said earlier, two forms, moss and yeast. Here it is the moss. Reproduction, they produce microponudia, some produce macroponudia, some both. This is the important part, how we classify. That is said earlier about the tissue involvement. It can be classified superficial and deep. So superficial and cutaneous goes as a superficial. Superficial mycosis, cutaneous mycosis. About the deep, it can subcutaneous, systemic, and opportunistic also term as superficial as well as deep. So when you recall with this idea, superficial, cutaneous, subcutaneous, systemic, opportunistic also. You can see superficial cutaneous. Here also subcutaneous included. So superficial cutaneous and subcutaneous. Deep mycosis means they involve in the tissues, brain, lungs, heart, liver, likewise. About the subcutaneous mycosis, there are mycetomas. You will understand later the cause. They cause subcutaneous infection. One example is mycetoma. Then they cause chromoblastomycosis, spirotrichosis, rhinosporidiosis. About the systemic mycosis, there are examples: cryptococcosis, blastomycosis, coccidioidomycosis, histoplasmosis, likewise. So classification is always superficial, cutaneous, subcutaneous, and deep or systemic. Bit of candidiasis related to the separate lectures there caused by candida species because it's very much important. It's a emerged pathogen, emerged fungal pathogen commonly found in hospital as a hospital-acquired infection among immunocompromised individuals. So it is one is opportunistic infection. It causes superficial as well as deep, including cutaneous and systemic. It's a terrible condition. We need to diagnose or detect earlier, more often in urine tract. Likewise, they come as contaminant. Vaginal colonization in the females that present as following UFR urine culture positivity. We have to balance the clinical picture. But when they cause infective endocarditis or device-associated infection, it's a terrible condition. About bit opportunistic infection in patient with debilitating diseases or altered physiological state. Aspergillus, penicillium, mucorrhizopus, there are a lot of organisms produce serious and fatal infection. About the uses, source of food, mushrooms, fermentation, production of alcohol, bread, cheese, antibiotic production, penicillium notatum, ergot from used to introduce uterine contraction, vaccines for hepatitis B, they produce from Saccharomyces cerevisiae. Diagnosis and treatment. Diagnosis grown in medium that selects from fungal. It depends, like bacterial. We can take the proper sample. If it is grown in the skin, we can take the skin scraping and go for KOH preparation and look through the microscope, as well as go for culture. If it is the blood, we take blood culture and do the processing. If it is sputum, same manner like bacteria, other infection, same manner. But depending on the morphology, depending on the identification, we go for fungal or bacterial, and therapy also there are antifungals available. Thank you.